Yes, sir.
Okay, okay. So basically, we are discussing some network is not working properly. Ah. Anyway, so am I audible now?
Yes, sir.
Do you see my screen?
Yes, sir.
Okay, so we have discussed discrete uniform distribution and binomial distribution. So these are some fundamental distribution, probability distributions, which frequently appears in many real life problems. So today we are going to discuss few more. Poisson will be one of them. Uniform distribution will be next one, and then normal distribution. So Poisson is discrete type distribution. So this distribution was introduced by French mathematician Simeon Denis Poisson. Huh? So it is Poisson distribution. Just a moment, spelling mistake. I is not there. Poisson. Poisson distribution. The Poisson distribution. So it was studied by French mathematician Denis Poisson or Poisson. Many real life problems such as car accidents in a given period of time, number of typing error in a page, failure of machine in 1 month, traffic flow, and many other problems can be modeled in terms of Poisson distribution. Now, how do you know that that is following distribution? Okay, so that will depend on the experience. If I ask you, okay, model car number of car accident in a given period of time, you may not come up with Poisson distribution, but after decades of study, the Poisson distribution has been uniformly granted that number of car accidents in a given period of time, number of patients coming to a hospital in any department, that follows Poisson distribution, provided no unnatural things are happening. For example, if earthwork if happening, then number of people will be coming. More number of people will be coming. If in natural scenario, that will be following Poisson distribution. Then now typing mistake in a given page, that will be following Poisson distribution. Many other diseases like leukemia, so that follows Poisson distribution. So what is that density function, or the not density function, mass function? In case of discrete it is mass function, in case of continuous it is density function. So the probability mass function of the random variable, which is of Poisson kind, is given by, so a random variable X is said to have Poisson distribution if its probability mass function PMF is given by, what is the probability mass function? F of X equals to probability. Basically, what is f of x? F of x represents the probability at the point x equals to small x, which is given by e power minus mu power x by factorial x. What is x value? Random variable capital X, assuming the value 0, 1, 2, 3, and so on. So these are the possible values of x. So you see, random variable capital X assumes countable number of points, 0, 1, 2, 3, and so on. So these points are discrete points. That is why the random variable X is discrete distribution. And what is the mass function? What is the associated mass for each of these random values? X equals to 0, 1, 2, 3. It is given by e power minus mu power x by factorial x. Now what is mu? So mu is fixed for a given Poisson distribution. It is known as the mean or expectation of the random variable and variance of the random variable. If we calculate expectation and variance, we'll come up with the number mu. We'll do it right immediately after that. So this mu will determine what kind of Poisson distribution you are considering. Otherwise, the rest of the part is same. Only mu is changing. For a different kind of situation, you will get different Poisson distribution. So it is only depending on mu. So and everywhere else it is 0. If x is any other value, then it is 0. Okay. So it is called Poisson distribution. So it is denoted as Ax is Poisson distribution with parameter mu. So what is the expectation or weighted average of the random variables? So expectation of Ax is what? Summation random variable into its corresponding weight. So summation xi pi, summation over I. So here sum is over I 0 to infinity. So I equals to 0 to infinity. Xi is what? Simple R or simple I into e power minus mu power I by factorial I. Okay. So this is, or if you are having confusion with I, then write x. X equals to 0 to infinity e power minus mu power x by factorial x. Here it also will be multiplied by x. Okay. Now you simplify it and see what is the value you are getting. So this is very simple to evaluate. So x will be cancelled out with factorial x. So it will be summation x equals to 0 to infinity e power minus mu power x by factorial x minus 1. So you take it outside e power minus mu, and you take 1 mu outside. So it will be summation x equals to 0 to infinity mu power x minus 1 by factorial x minus 1. So can you tell me what is the series inside series? What is this? What is that series?
e power x minus 1?
No, just a moment. Just a moment. For x equals to 0, when you put x equals to 0, so factorial 0 is 1. So at the denominator it is 1, but numerator is 0. So total value will be 0. So it will be starting from, so you can neglect the first term. So it will be starting from x equals to 1 to infinity, x e power minus mu power x by factorial x. Now from there, so this sum is I equals to 1 to infinity. Sum equals to I. Okay. So you now change the index. So it will be e power minus mu into summation r equals to 0 to infinity mu power r by factorial r. Okay. So what is this series now? Now it is known
e
to
raised
you.
to
E raised to power minus mu, e raised to power mu. So it is e power minus mu into e power mu. So e power minus mu and e power mu will be cancelled out. So it is mu. So the average value of the random variable, I'm not saying general average, it is weighted average. Each random variable into its corresponding weight. So that kind of average we are considering. So weighted average of the random variables is given by mu for this distribution. What is variance of x? So variance of x formula is what? Var of x is e of x minus mu whole square. So it is written as e of x square minus mu square. So just like the previous calculation, you have to simplify it. Now, since factorial is mentioned in the distribution, so what we are going to do, we are not going to use this formula. We are going to use the alternative formula. We have one more. Let me show you. We discussed it at some point here. Not this one. This one. So we are going to use this formula to evaluate variance of x. Expectation of x into x minus 1 minus mu into mu minus 1. So that formula we are going to use. So variance of x, this will be expectation of x into x minus 1 minus mu into mu minus 1. So by definition, it will be summation x equals to 0 to infinity x into x minus 1 e power minus mu power x by factorial x minus mu into mu minus 1. So what is it? So if you write down, so for first two term, it will have 0 contribution. So the sum can be written as x equals to 2 to infinity x into x minus 1 e power minus mu power x by factorial x minus mu into mu minus 1. So that will give you, so now you expand the factorial in the denominator. So that will give you summation x equals to 2 to infinity x into x minus 1 e power minus mu power x by factorial x minus 2 x into x minus 1 minus mu into mu minus 1. So that will give you this part and this part is cancelled out. So it is x equals to 2 to infinity e power minus mu power x by factorial x minus 2 minus mu into mu minus 1. So from here e power minus mu and mu square is taken common from this summation. So inside part will be x equals to 2 to infinity mu power x minus 2 by factorial x minus 2 minus mu into mu minus 1. Now you change the index from x to something else so that it starts from 0. So e power minus mu square r equals to 0 to infinity mu power r by factorial r minus mu square plus mu. So this is what? E power minus mu into mu square e power mu minus mu square plus mu. So this is cancelled out, e power minus mu and e power mu. So mu square plus mu square minus mu square plus mu. So it is coming plus mu. So variance of standard deviation, variance of Poisson distribution is what? Mu. So these two parameters. So the Poisson distribution is completely determined by the parameter mu. If mu is known to you, everything else is known to you. So let us consider few problems using this distribution. Just a moment. So here 24, problem number 24. Okay. So the problems are given in this way. The number of traffic accidents per week in a small city, per week in a small city has a Poisson distribution. As a Poisson distribution with mean equal to 3, with mean equal to 3. So mean means mu is known to you, mu is 3. Number of traffic accidents per week in a small city has Poisson distribution with mean equals to 3. What is the probability? What is the probability? What is the probability that what is the probability of exactly 2 accidents occurring in 2 weeks? Occurring in 2 weeks. Okay. So this problem, what is given, that the distribution follows Poisson distribution. What is the mean? Mean equals to 3. So what is mean? Number of ट्रैफिक एक्सीडेंट्स पर वीक. सो हर एक वीक में 3 एक्सीडेंट्स होते हैं on average. Okay, what is the probability that exactly 2 accidents occurring in 2 weeks? तो आपको 2 weeks में फाइंड करने हैं. तो जो एवरेज वैल्यू है that also has to be converted to average in 2 weeks. So if 3 accidents occurring per week, then how many accidents are happening in 2 weeks? On average 6. So let x be the random variable. Let x be the random variable which follows Poisson distribution. Okay. Now, what is mu? Mu is 6 per 2 weeks. 6 accidents per 2 weeks. Why we are converting to per 2 weeks? Because we have to find out the probability of exactly 2 accidents occurring in 2 weeks. So जो हम लोग बाइनमी जो पॉइसन डिस्ट्रीब्यूशन कंसीडर करेंगे उसमें जो मीन आएंगे that will be number of accidents per 2 week. So that is what we have converted. Now what is the Poisson distribution? Poisson distribution is given by f of x is equals to e power minus 6 into 6 power x by factorial x. X is 0, 1, 2, 3 and so on. So we have completely known Poisson distribution. Now what we have to find out? Exactly 2 accidents occurring. So these random values, these values obtained by the random variable x equals to 0, 1, 2, they represent the number of accidents, total number of accidents per week. So these values denotes the total number of accidents. These denotes or this number represents total number of accidents per 2 weeks. Per 2 weeks. So what is the question? What is the probability exactly 2 accidents occurring in 2 weeks? So what you have to find out? Probability that the random variable x is assuming the value 2. Probability of x equals to 2. So it will be e power minus 6, 6 power 2 by factorial 2. So how much you are getting if you evaluate numerically?
E raised to minus 6 by 20.
Just a moment. So question was just available. Let me look at the question one more time. The number of traffic accidents per week in a small city has Poisson distribution with mean equals to 3. What is the probability that exactly 2 accidents occur in 2 weeks? So first we have converted the mean per 2 weeks. Then we have written the Poisson distribution. Now we are following how many accidents we have to find out? 2 accidents. So what is the probability that the random variable is assuming the value x equals to 2? So it is given by e power minus 6 into 6 power 2 by factorial 2. So it is how much you are getting? 18 into 18 into e power minus 6. What is the numerical value? What is the numerical value? Let me find out.
Sir, 0.0446.
0.0446.
4461.
Okay, so this much probability is there that two accidents will be occurring per 2 weeks. So now you can use this distribution to find out any probability. What is the probability that at least one accident will be occurring per 2 weeks? So how to find out that? What is the probability? Next question is, if I ask you, what is the probability that at least one accident is occurring per 2 week? So what you have to do? You have to find out the probability that the random variable x assumes the value greater than equals to 1. Yes or no?
Yes, sir.
Because these values denotes the number of accidents per 2 week. So what is the probability that the random variable x assumes the value greater than equals to 1? So what it will be? It can
1
be written
minus
as if 1 minus
probability of no
x
accident.
equals to 0. It will be a simpler way to write. It will be easier way to write. Otherwise, if you keep on adding for x equals to 1, x equals to 2, x equals to 3. So total probability is 1 and only other random variable is 0. So 1 minus probability at x equals to 0. So it is 1 minus e power 6, e power minus mu power, so 6 power 0 by factorial 0. 6 power 0 by factorial 0. So it is 1 minus e power 6.
Sir, e power minus 6 था ना?
E power minus e power minus 6. Otherwise, it will be large quantity. Sorry, 1 minus e power minus 6. So it is certain, almost certain. You see, it is almost close to 1. It is almost close to 1, is not it?
Yes, sir.
So it is certain that at least one accident will be happening per 2 week. So this is the way you have to explore Poisson distribution. Another type of question I can, if you search, I will share the study material. Another kind of problem can be modeled in terms of Poisson distribution. A call center received an average of 4.5 calls per 5 minutes. So let me write down the problem. You have a call center. Okay. It is problem number 25. Okay. So call center on average receives 4.5 calls. So this is their data. 4.5 calls per 5 minutes. So this average can be determined by 1 minute or by 60 minutes. So in 1 minute, how many calls will be there? 4.5 by 5. So you can manipulate this average. It does not matter. So call center receives on average 4.5 calls per 5 minutes. Okay. Each agent or each person, each agent can handle each agent can handle one of these calls over 5 minute period. 5 minutes period. Okay. So call center receives 4.5 calls per 5 minutes. Each agent can handle one of these calls over 5 minutes period. If a call is received by call center, okay, if a call is received by call center and no agent is available to receive the call and no agent is available to receive the call, then the caller will be placed in hold. Placed in hold. Okay. So we are assuming that the calls follow Poisson distribution. It is universally taken that number of calls in a call center that follows Poisson distribution. So we are following that. We are assuming that. So what is the minimum number of agents needed? So what is the minimum number of agents or persons needed on duty so that calls are placed on hold. Calls are placed on hold at most 10% of the time. At most 10% of the time. So I will not be solving the whole equation. I will just write down the equation for you and then you have to solve it. So let X be the random variables which denotes or which represents the number of calls placed on hold. Okay. Let X be the random variable which represents, so solution. So you have to choose the random variable. So let X be the random variable which denotes the number of calls placed on hold. So what we have to find out? We have to find out that the number of call placed on holds does not exceed 10%. So probability that the random variable X is assuming the value greater than equals to K. Probability that the random variable X is assuming the value K, that should not be greater than 10%. So it should be less than equals to 10%. So what is 10%?
0.1.
0.1. So this is the equation you have to solve. Okay, everything else is given to you. So from this equation you have to determine what is the value of K. So this will be, in short, 1 minus probability that the random variable x is assuming the value less than equals to k, that should be less than equals to 0.1. Now what is probability that the random variable x assuming the value less than equals to k? So it is probability at x equals to 0 plus probability at x equals to 1 plus probability at x equals to 2 up to probability at x equals to k. And it is given what is mu? Mu equals to 4.5. So from there, these probabilities will be completely known to you, and then you determine, and from there you evaluate the value of k. Okay, so I am leaving this calculation up to you. So this is how real life scenarios can be modeled in terms of Poisson distribution. Many other applications are there. Now we are going to discuss continuous random variables. Continuous random variables. Continuous random variable. So we are going to consider two continuous random variables. They will be uniform distribution okay. Just a moment. Uniform distribution. So a random variable x, is said to have uniform distribution if its probability density function is given by, so uniform distribution on certain interval a comma b with minus infinity less than a less than b less than plus infinity, if its probability density function PDF is given by fx of x equals to 1 upon b minus a when x belongs to the interval a comma b and 0 elsewhere. So you see, random variable x assumes all the values. Let me write it clearly. It is a open, b closed. When x belongs to, it does not matter because probability at a single point will be 0 for continuous random variable. So you see, this random variable x assumes all the values in the interval a comma b. So if a random variable takes all values in a certain interval, then it represents continuous random variable. So its probability density function is given by 1 upon b minus a whenever x belongs to a comma b. So for all points in the interval x belongs to a comma b, its probability density function is given by 1 upon b minus a. So if this is the probability axis and this side is a random values axis x, then suppose this is the interval a b, then probability density function, if you plot it, it will be 0 up to the point a, then from a to b it will be a constant number 1 upon b minus a. So this much, this represents 1 upon b minus a, and again 0 from b to infinity. So this will be the probability density function. What will be the criteria? The area bounded by this curve, there has to be 1 unit, then only. So it is 1 in this case. If you integrate minus infinity to plus infinity, 1 upon b minus a, I should not write 1 upon b minus a, I have to write f of x dx. F x of x dx. So it is 0 elsewhere, only non-zero values in the interval a to b. So it is integration a to b fx of x, not fx of x, now it will be 1 upon b minus a. Let me write down properly. Minus infinity to 0, minus infinity to a fx of x dx plus a to b fx of x dx plus b to infinity fx of x dx. So these two are 0 because function is defined 0, integrand is 0. The non-zero value we are getting integration a to b. And what is the value? What is the integrand in the interval a to b? It is 1 upon b minus a. 1 upon b minus a dx. So it is 1. So this is indeed a probability density function. Now expectation and variance, I am leaving this part to you. Find out the expectation of this random variable and variance of this random variable. This is very easy. Let me write down the numbers. You do it yourself. It will be a plus b by 2, weighted average of the probability density function. So basically it will tell you where is the center of mass of this car. And variance of x will represent the moment of inertia perpendicular to the axis and passing through the center of mass. So it will be, this will be the number b minus a whole square by 12. So this is very easy. You just use the integration definition. How can you obtain it? Expectation of x will be integration minus infinity to plus infinity, or since it is 0 elsewhere outside of a to b, so you can directly start with integration a to b x f of x dx. That will be expectation, and variance will be, use this formula, expectation of x square minus u of x whole square. You use this formula. Okay. Next one is most important. This is a normal distribution. Whenever from the last semester onwards, the grading for undergraduate students is, that will be determined by relative grading or absolute. It will be relative grading. So whenever we are adapting relative grading, we have to follow this normal distribution. We have to find out total number of students in the class. Then we have to find out the variance and standard deviation, and then we have to determine from which interval to which interval what grade will be given. So we follow this normal distribution. We pre-decide that top 10% students will be given excellent, maybe, or it will be determined by the examiner. So 10% students will be given excellent grade, then next 20% or 15% student will be given next possible grade, then next 20% next possible grade, and so on. So if we strictly follow this normal distribution, some of the students are obviously going to fail the subject because the nature of the normal distribution. So normal distribution, when the data points are small, then it is not advised to follow the normal distribution because you do not have enough data, and you need a bit more data to create a smooth normal curve. Anyway, so what is the normal distribution? So it is a continuous distribution whose probability density function is given by fx of x is equals to 1 upon root 2 pi sigma e power minus x minus mu whole square by 2 sigma square. So what is the possible value of the random variable? Random variable takes all values in the interval plus infinity, minus infinity to plus infinity. So minus infinity to x. So this is the distribution, normal distribution. F of ax is equals to 1 upon root 2 pi into sigma into e power minus x minus mu whole square by 2 sigma square. So if you follow the above definition of expectation and variance, you will come up with these two numbers. I will leave that as homework to you. Expectation will be coming as mu and variance will be coming as sigma square. Okay. So standard deviation will be positive square root of variance, so it will be sigma. So that will be positive square root of variance of the normal distribution, so it is sigma. So these are the parameters: expectation, variance, and standard deviation. Now if we plot this in 2 dimensions, the graph will look something like this bell shape. So x equals to mu, suppose here sigma, the deviation from the mean, so it is this much height, then you will have this kind of shape. It will be 0 as x tends to minus infinity. Again it will be 0 when x is tending to plus infinity. So the shape will be something like this, and this bell shape or sigma curve. So total area under this curve is going to be 1 unit. Total area under this curve is going to be 1 unit. And you see this curve is symmetric about x equals to mu. So area on the both side of this line x equals to mu, they are same. So this side is sigma, the deviation, and mean is mu. So we determined, for example, when evaluating the grades, we determined maybe first 10% students will be given excellent grade, then next 15% next possible grade, and so on. So if you keep on doing this, on the left hand side you see the curve will go on both sides up to plus infinity and minus infinity. So whatever interval you consider from A to B, the part has some portion. So according to this, if we follow this curve, this sigma curve, this normal distribution, then some student obviously going to fail. So how to determine the grades properly, so that will not be discussed, but some equivalent problem will be discussed in using this normal distribution in the next theory class. So your homework is to find out, to complete the calculation for expectation of the distribution and variance of the distribution. This will be bit tricky because while evaluating the gamma function will be used. Have you studied gamma function?
Yes, sir.
What is gamma function? What is gamma of x? What is the gamma function?
Sir, e power minus x t x minus t power x minus 1 dx.
X power t power e power minus x.
T power x minus 1
Then it has to be gamma t. Then it has to be gamma t. If you are saying that, then gamma t is e power minus x, x power t minus 1 dx. Okay. So this is gamma function. Integration 0 to infinity e power minus x, x power t minus 1 dx. Is not it? Is it okay? Any mistake is there? And what is the value what is the range when this gamma function will be well defined? What is the range of t? What is the domain when this gamma function is defined? It is an improper integral. आप लोगों ने पढ़े है ना मैथमेटिक्स 1 में. So this gamma function is well defined when t greater than 0. So गामा हाफ की वैल्यू जरूरत होंगे और कुछ इंटीग्रेशन स्टैंडर्ड इंटीग्रेशन की वैल्यू जरूरत होंगे. व्हाट इज इंटीग्रेशन 0 टू इंफिनिटी e पावर माइनस x स्क्वायर dx root pi by 2. So this standard value will be used. Gamma half equals to root pi, that also will be used. So please complete the calculation. Okay, so I'll stop the discussion at this point. In next theory class, we are going to solve some problem using this normal distribution, and then we'll consider regression analysis. So two more classes are required to complete the syllabus. Okay, so I'm stopping the class. If you have any doubts, you can ask me. If not, you may leave the class. First result, I'm not quite sure. E power minus x squared dx is whole root pi by 2 or root pi by 2? This one or this one? Integration 0 to infinity e power minus x squared dx is, I think, the written one.